Good morning, students. Today we are going to discuss about structure of atom and some of its topics. We had already discussed till now the discovery of subatomic particles, atomic number, mass number, isotopes, isobar, isotones and isoelectronic species. So let us start some more topics in structure of atom. So today we are going to discuss about electromagnetic wave theory, means the developments leading to the Bohr's model of an atom, that is electromagnetic wave theory, characteristics of a particular wave, electromagnetic spectrum and limitations of electromagnetic wave theory, special especially on black body radiation and photoelectric effect. So let us begin. So it is observed that all elements give characteristics line spectra which could not be explained on the basis of Rutherford's nuclear model of an atom. Till now we have discussed about Rutherford nuclear model. So in order to understand the line spectrum, it is essential to understand the nature of light, which in turn was explained first on the basis of electromagnetic wave theory and then by Planck's quantum theory. This we will discuss later on. So further, with the advent of this theory, it was found that Rutherford model of atom suffered from a serious drawback. We had also discussed about the drawbacks of Rutherford model. So hence, a new model of atom called Bohr's model of atom was put forward. This model of atom was able to explain the Rutherford model of atom and the main lines of hydrogen spectrum. So now let us discuss wave nature of electromagnetic radiation, that is electromagnetic wave theory. So this theory was put forward by James Clerk Maxwell in 1864. The main points of this theory are as follows. The first one is that the energy is emitted from any source like the heated rod or the filament of a bulb through which electric current is passed continuously in the form of radiations, and this radiations is called radiant energy. This is the first point. And the second one, the radiations consist of electric and magnetic fields oscillating perpendicular to each other and both perpendicular to the direction of propagation of the radiation. You can see over here electric and magnetic fields, the radiations are both are having both the components, so both of them are perpendicular to the direction of propagation of the radiation. You can see over here. Let us proceed towards the third postulate, that is the radiations possess wave character and travel with the velocity of light. And you are knowing the velocity of light, it is nearly equals to 3 into 10 to the power 8 meter per second. So because of the above characteristics, the radiations are called electromagnetic radiations or electromagnetic waves. Now the last one is, these waves do not require any material medium for propagation. So these are the most important points of electromagnetic wave theory. That first one is about radiant energy. The second one is about electric and magnetic fields which are oscillating perpendicular to each other, and third one is about the radiation is possessing wave character, and the fourth and last one is about the waves do not require any material medium for propagation. So now for example we can say the rays which are coming from the sun, those are reaches through us through the space, which is also a non-material medium. It is reaching to the earth. So now before proceeding, let us have a look upon some important characteristics of a wave. So you can see over here we have taken an example of wave. So the main characteristics of a wave are, first of all, its wavelength, frequency, velocity. You can see over here the upper part is known as crest and the lower part of the wave is known as trough. So firstly, these let us define these small terms. The first one is about wavelength. It is defined as the distance between any two consecutive crests or trough. You can see over here wavelength is being shown. So it is represented by the symbol lambda and is expressed in angstrom or meter or centimeter or nanometer, picometer as well. So this is wavelength. Next one is frequency. Frequency of a wave is defined as the number of waves passing through a point in 1 second. Means it is represented by nu and is expressed in hertz or cycle per second, or simply we can say it's per second. As we are knowing, 1 hertz is equals to 1 cycle per second. So next one is velocity. It is defined as the linear distance traveled by the wave in 1 second. Simply, it is represented by small c, or its unit is meter per second or centimeter per second. Beside these three characteristics, the two more important characteristics of wave are amplitude and wave number. So amplitude of a wave is the height of the crest. You have just seen in the diagram, it is the height of the crest or the depth of the trough. It is represented by small a and is expressed in the units of length. And about wave number, it is defined as the number of waves present in 1 centimeter length, or it is equal to the reciprocal of wavelength. It is also represented by nu bar. Nu bar we can write it as 1 upon wavelength. So it is expressed having the unit per centimeter or per meter. So now this is all about the characteristics of a wave. So there is one very simple relationship between velocity, wavelength and frequency of a wave, and that can be represented as c is equals to nu into lambda. So here c is the velocity of light and nu is the frequency and lambda is the wavelength. So using this very formula we can solve many questions. So let us discuss one of them. So now the electromagnetic spectrum. Before starting electromagnetic spectrum, after this we will discuss one questions as well. So electromagnetic spectrum first of all. So the different types of electromagnetic radiations differ only in their wavelengths and hence frequencies. So their wavelength increase in the following order. Electromagnetic spectrum is the spectrum consisting of these rays: cosmic rays, gamma rays, X-rays, ultraviolet rays, visible rays, infrared rays, microwaves, radio waves. These all are the electromagnetic waves, and these are arranged on the basis of their increasing wavelengths. You can see over here. So now we can define what is electromagnetic spectrum. When these electromagnetic radiations are arranged in order of their increasing wavelengths or decreasing frequencies, the complete spectrum obtained is called electromagnetic spectrum. Or you can see over here the visible range of the electromagnetic spectrum in terms of nanometer. We can say 380 nanometers to 760 nanometers. Okay, so this is the visible range which we can see the colors, that is Vibgyor. V for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange and R for red. So this is the visible region, which the colors which we are able to see. And about gamma rays, X-rays, ultraviolet region is there, infrared as well, radio waves as well. So these are arranged on the basis of their increasing wavelengths. So now there is some limitations of electromagnetic wave theory. So electromagnetic wave theory was successful in explaining the properties of light such as interference, diffraction, etc. But it could not explain the following, like the phenomena of black body radiation, the photoelectric effect. These two we will discuss in detail, what is black body radiation and what is photoelectric effect. And the variation, another limitation is the variation of heat capacity of solids as a function of temperature. I hope all of you are knowing what is heat capacity. So heat capacity, we can define it as the amount of heat energy required to raise uniformly the temperature of the substance of the solid by 1 unit or by 1 degree. That is heat capacity of solids. Its unit is joule per Kelvin. And the last limitation is the line spectra of atoms with special reference to hydrogen. So now this is one of the example which we are going to discuss on that very numerical, that is C is equals to nu into lambda. So the question is like this: you have to calculate wave number first and then frequency as well of yellow radiations having wavelength of 5800 angstrom. So question is this one. Now you have to calculate. So for calculating wave number, we are knowing that wave number is equals to reciprocal of wavelength. So here we have been given the wavelength, that is 5800 angstrom. So we can write it in terms of meter, that is 5800 multiplied with 10 to the power minus 10 meter. So now for calculating wave number, just we have to divide 1 divided by wavelength. So after dividing, we are getting the wave number 1.72 into 10 to the power 6 per meter. This is the unit of wave number. Now after calculating wave number, we have to calculate frequency. Now applying the same relationship, that is C is equals to nu multiplied with wavelength. So here we have to calculate nu. So for calculating nu, then nu will be equals to C divided by lambda. So C here 3 into 10 to the power 8 meter per second, and lambda we are knowing. So after dividing both of them, we are getting the nu, the frequency of the yellow radiations, that is 5.172 into 10 to the power 14 per second, or hertz we can write. So I hope you have understood this very question for calculation of wave number and frequency of yellow radiations. So now, just now we have discussed the limitations of electromagnetic wave theory, and with special reference to black body radiation and photoelectric effect. So let us first discuss what is black body radiation. Now if any substance with high melting point, suppose we are considering an iron bar, then it is heated. So first it becomes red and then yellow, and finally it begins to glow with white and then with blue light. So we can define black body radiation as like this: if the substance being heated is a black body. Black body means which is a perfect absorber and perfect radiator of energy, that is which can emit and absorb all frequencies of radiation, all electromagnetic radiations having different frequencies. So the radiation emitted is called black body radiation. Means if a substance being heated is a black body, then the radiation which is being emitted by that very body is called black body radiation. This phenomena is called black body radiation. So according to electromagnetic wave theory, the energy is emitted or absorbed continuously, we are knowing. So hence the energy of any electromagnetic radiation is proportional to its intensity, that is square of amplitude, and is independent of its frequency or wavelength. Thus, according to the wave theory, the radiation emitted by the body being heated should have the same color, although its intensity may vary as the heating is continued. So the change of color shows that on heating, the frequency of the radiation emitted is increasing, as red color lies in the lower frequency region having the highest maximum wavelength. So that's why it lies in the lower frequency region, while blue color lies in the high frequency region, that is having the less wavelength. So now we can see over here, student, the variation of intensity with the wavelength at two different temperatures or at 3-4 different temperatures. So you can see the graph between intensity and wavelength. So using this very graph, what we can conclude? We can conclude that at a given temperature, the intensity of radiation, just see very carefully, the intensity of radiation emitted increases with decrease of wavelength, and reach it further, it reaches a maximum value at a particular wavelength, and then it starts decreasing with further decrease of wavelength, that is from right to left in the given graph over here. So I hope you have understood the graph, how it is the intensity and wavelength of any wave is varying. Okay, so let us proceed. The next limitation is photoelectric effect. So what is photoelectric effect? When radiations with frequency greater than a certain minimum frequency, that is nu naught, strike the surface of a metal, the electrons are ejected from the surface of the metal. So this phenomena is called photoelectric effect, and the electrons which are emitted are called photoelectrons. You can see over here in the diagram, when radiations with certain frequency greater than a minimum frequency, it is striking the metal surface, then electrons are being ejected out from the surface. So this phenomena is known as photoelectric effect, and the electrons which are emitted are known as photoelectrons. And also see the next diagram, that is apparatus for studying photoelectric effect. So the apparatus which is used for studying the photoelectric effect is shown as in this very figure. So it is consisting of an evacuated tube fitted with a metal surface which is to be exposed as cathode, and a suitable detector is there as anode, and then it is being connected to the external circuit, as you can see over here. When light of sufficient energy is allowed to strike the surface of the metal, electrons are ejected, which move towards the detector. By observing the amount of current flowing, the kinetic energy of the electrons can be determined. So this is the process which is occurring in this very apparatus. So we can, using the photoelectric effect, we can observe the following important facts, which are as follows. So the three important facts which are observed about the photoelectric effect is, the first one is that the electrons which are ejected only if the radiation striking the surface of the metal has a frequency greater than a minimum frequency, that is nu naught, and if the frequency is less than nu naught, then no electrons are ejected, and this value nu naught is called threshold frequency. It is the minimum frequency and below which no electrons will be ejected. So now after this, one more important term, that is stopping potential. So the potential applied corresponding to this threshold frequency is called stopping potential, means the voltage which is applied to this very corresponding frequency. So that is stopping potential. As we are knowing, current flowing up to this frequency is 0. And one more important term is work function. So work function is the minimum energy above which the electron is ejected, and it is denoted as W naught. And there are various values for a few metals, like for work function for potassium is 2.25 and for sodium it is 2.30 electron volts. The unit for writing work function is electron volts, and these values will be given to you in the question. So the next and important fact is the velocity of the ejected electrons depends upon the frequency of the incident radiation, and it is independent of its intensity. And the third one is the number of photoelectrons ejected is proportional to the intensity of incident radiation. I hope these three facts are very clear to all of you. These are simple three facts, and these three facts cannot be explained by the electromagnetic wave theory. According to this theory, since radiations are continuous, therefore it should be possible to accumulate energy on the surface of the metal irrespective of its frequency, and thus radiations of all frequencies should be able to eject electrons. Similarly, according to this theory, the energy of the electrons ejected should depend upon the intensity of the incident radiation. But just now we have discussed that the velocity of the electron ejected depends only upon the frequency of incident radiation, and it is independent of its intensity. So that's why these two important phenomena, that is black body radiation and photoelectric effect, are the limitations where electromagnetic wave theory was failed to explain these facts. So I hope this is clear to all of you. So today we have discussed about the electromagnetic wave theory, about the photoelectric effect, and about the black body radiation. Means these are the limitations of electromagnetic wave theory. Thank you, students.